Hi, this is Miss Fitzmaurice, and this video is an introduction to circuits. So by the end of this video, you should be able to explain what's happening on the microscopic level as a light bulb lights up. You should also be able to define voltage, current, and resistance. And the last thing we're going to do is we're going to talk about these two new equations, and we're going to call them Ohm's law and our power law. Alright, so first we're going to talk about what's happening at the microscopic level. And we're going to start out with the battery. Now you can think about the battery as having two parts, and you've seen them labeled. We have a part that is a negative end and a part that's a positive end. Now, if you remember from chemistry, all atoms, and this is a very simplified picture, but all atoms in your bulb are going to have both protons and electrons, but the positive end has more protons, so there's like missing electrons, and that's why it has an excess or a net positive charge. Now the negative end, we can say it has more electrons. Okay, and hopefully you also remember from chemistry or third grade science that if you have two like charges, okay, so say you had two electrons and they're both negative, they repel each other, okay? If we were to draw forces on them, they would be pushing each other away from each other. And we know that opposite charges, if you have a plus and a minus, they're going to attract and they're going to be pulled towards each other. So our battery, there's some kind of barrier inside, and in one side we have too many protons, and all that positive charge doesn't really like each other. The protons are pushing away from each other, but they're kind of stuck. They have to stay there. And in our negative side, we have too many electrons. Okay, so having an excess amount of electrons, the electrons don't like each other. And they would prefer to be able to move somehow over to the side where there are too many protons. So they don't like each other, and they would like to move over to the side that is positive. And what we can do, and what you saw probably today, is if you connect the two ends of the battery with some kind of metal wire, electrons can move through metal, and so you have all these electrons on the negative side of the battery. They don't like each other, and so they want to move through the metal wire until they get to the positive end. And they're going to keep doing that and doing that and doing that until eventually you wouldn't have a negative side over here. You would just have a neutral side because all of the electrons, all of the extra electrons would have moved over to the positive side. And that's when your battery runs out. So what's happening, and we're going to relate this back to physics, is that the electrons are pulled through the wire by a force exerted on them by the positive end. Now the next thing we have to talk about is, what about the light bulb? So you guys should have seen today that the way to get a light bulb to light up would be if you connected not just a wire to each end of the battery, but you connect the wire to one end of our light bulb and then connect another wire, or you could use just one wire and connect the light bulb directly to the battery, but you're essentially forcing your electrons in order to get to the side of the battery they want to get to. They have to go through the light bulb as well. And if you were to look at the inside of a light bulb, there's a little wire that comes up from the bottom, goes through the glowing part that you can see, and it connects up to the side. So these electrons really do go in a loop. And as they pass through the light bulb has some kind of filament resistor in it. And as the electrons pass through it, they lose potential energy. Okay, kind of like I talked about if you had an atom that had its electrons up in an excited state and fell down to a lower orbital. So the electrons lose potential energy when they go through a light bulb, and as a consequence, they create EM waves, and it gives off some light. Okay, so this is a very basic explanation of what's going on when we have a battery and we're able to light up a light bulb. Now, in terms of energy, our electrons, okay, when they're at the negative end, they're stuck with a bunch of other electrons they don't like. They have a lot of potential. Okay, they feel very compelled to start moving. Okay, so at the negative end, the electrons have a high potential energy, and we're going to call it an electric potential energy. And by the time they flow through the light bulb and get to the positive side, okay, they lose potential energy as they flow through the light bulb. And they're at a low potential energy by the time they get back to the other end of the battery. Alright, so the next thing I'm going to do is I'm going to go over some definitions. When you're going through these definitions, and pretty much the whole time we're going through circuits, it's really useful to kind of go back to the idea of flowing electrons and kind of relate it back to flowing water. So the definition of current, okay, for water, it would be how fast water is flowing through a certain area. For an electric circuit, current is the amount of charge flowing through a circuit per unit time. Okay, and the unit for current is amps. Okay, but you'll usually just see me write A. Now, just like if you have water flowing through a pipe, sometimes that water will meet resistance. Okay, something will be blocking it. And so resistance in an electric circuit is how difficult it is to get electrons through a circuit. Okay, and this is measured in this weird unit. It's called ohms. Okay, but the symbol for ohms is not O, it's the Greek letter omega. So it looks kind of like a horseshoe. Okay, and then the last one we're going to go over is voltage. Okay, you can probably guess that the unit for voltage is volts, and we'll usually abbreviate it as V. And voltage is the potential energy per unit charge. So if you look at a battery and you see 1.5 volts, that means each electron only experiences a certain potential energy when it's stuck at that negative end. But if you see a 9-volt battery, that means that at that negative end, you probably have each electron has a much higher potential energy. Alright, and the last thing I'm going to do is I'm going to introduce to you today two equations. So our first equation is called Ohm's law. And Ohm's law is kind of the definition of resistance. So resistance is equal to the voltage you apply divided by the current that gets through. Okay, so the R stands for our resistance. Again, that's in ohms. The I stands for current in amps, and the V stands for voltage. Okay, the power law tells us that the amount of energy that's put out by a circuit in a given time. So think about it as energy put out by circuit in a given time. Okay, but it's just power like before, which is in watts. So the power, it depends on the current, so how many electrons or how much charge is going through your circuit per second, times the voltage. Okay, so again, current is our I, that's in amps, and voltage is in V.